Let us write a program, LMC program, for A plus B minus C. For that, we need a pseudocode and a flowchart. So we can represent any one of them is fine. If you are comfortable with pseudocode, kindly proceed with the pseudocode. Or if you are comfortable with the flowchart, continue with the flowchart. The remaining questions, maybe I will be using the flowcharts. So for performing A plus B plus C, there are 3 operands and 2 operators. Therefore, we need 3 input and perform 2 operations. So the first step is taking the input A, then input B, and then input C. After taking all the 3 input, we are going to perform addition between A and B. Temporarily, the accumulator stores A plus B. Followed by this is the next step of subtraction. We do what we have stored with the accumulator, we subtract C. Now whatever is there in the accumulator, we would like to give it as output, and therefore we output the result. The same thing is represented in the pseudocode. First we receive input A, then B, and then C. Then we perform the addition and store it in the accumulator. Then we perform subtraction and subtract C from the accumulator, and then we get the output. We just give it out on the output screen. So let us see how we can develop this program in our LMC file. So on LMC, I would like to write the very first line. So that is program. Now this is a comment, and then I take the first input. So after the first input, I don't know where is the second input, where is the location of it to be stored. So temporarily, I have to write something called 00. Then I take the second input and then I store it again at some location. Then I take the third input and then I store it again at some location. Once that is done, what I need to do is the addition of A plus B and then subtraction of C. So for that, what I need to do is I need to load what is at first location. Then I add the second location and then I subtract the third location. Whatever is the output, I will give it out and then I write the hold where the execution stops and my data section begins. Now here, when the execution stops and my data section begins, it's very clear I need storage of 3 variables. Therefore, I'm defining 3 data locations initialized with value 0. Now, I know the location of where my storage of data is, so I can replace the address field now with the exact location. My first value should be stored at 11. My second value should be stored at 12. And my third value should be stored at 13. Thereafter, we load the first value, that is 11. Then we add the second value to the first value, and then we subtract the third value from the resultant accumulator. Whatever is in the accumulator comes out and the program execution stops. No sooner the program execution stops, we have this halt statement which stops the execution. Let us run this program. I'm asked for the first input. Suppose I give 10 as an input as a first. You will see the replaced value here once it gets stored. Now this value will be replaced with 10. The second value is 20. we send it to LMC, and this value is replaced with 20. Now the third value, which is going to be, I want to deduct 5. So out of 20, if 5 goes off, the output should be 15. We send it to LMC, and we can see the output is 25. So 10 plus 20 minus, so 10 plus 20 minus 5, that is 30 minus 5 gives us 25. So if we clear the source log and the interpreter log, if we again try to run it with new input, let us give 10, and then we give 20 or maybe 30. So now the total is 40, and if I deduct 10, it should give me 30 as output. And yes, it works fine. And therefore, our program suffices the requirement for addition of 2 numbers and subtraction of 1 number.